This integral then, here's our integrand here, between the interval of 0 to 1, so we need to work out this according to the trapezium rule. We need to specify there's 5 ordinates, so we're going from 0 to 5 with 5 ordinates, so that would mean there's 4 intervals. So if we divide this interval length 0 to 1 by 4, we'll get the value of h. So here h is equal to this 1 minus 0, isn't it? 1 minus 0 over n, which we said was 4, the number of intervals, is a quarter, is 0.25, isn't it, as a decimal. So here then, we need to get, let's write down x0, x1, x2, x3 and x4 first to get these x values, and then we can get the corresponding y values. So 0 will be the first one, 4 will be the last, x4, which is 1. Then we're dividing it into 0.25s, aren't we? So if we jump up by 0.25, and then another one, and then another one, and then we get our 5 ordinates. Now we need to work out y0, y1, y2, and then y3 and y4. If we label this as f of x, this integrand here, then we can simply write f of 0, and this is f, let's save a bit of time, 0.25, and this is f 0.5, and we can type it in the calculator. As long as we're accurate, we'll be okay, and this is f of 1. So what are they equal to then? So let's tap them out then, so we know our calculator. So the first one will be this, to the power minus 0.5 with x equals 0 in. So we'll do bracket 2 minus 0 cubed. There's that. Close bracket. To the power. And then it's negative 0.5. Minus a half, in other words. So that equals 0.70711. 0.70711, wasn't it? Because we're working to 3dp. So if we do the calculations to 5, we should have a sufficiently wide margin of error. Let's put the next point in now. Now that makes life easy now for the next point, because we're going to put in 0.25. So instead of 0, we replace that with 0.25, if I can write it. There we go. 0.70989. 70989, isn't it? 70989. Just check that. Yeah, that's fine, because that 8 rounds up to a 9. Next one is 0.5. Let's go back then and write in 0.5. 0.73030, isn't it? 73030. There we go. And now the next one, put 0.75 in instead of 0.5. 79603. Just check that. 79603, yeah. And then the 1. Oh, it would be 2 minus 1 cubed. Let's just do it anyway, because that should work out as 1, yeah, which it does. So there's our values then. So now we put them in the formula. The interval value, which I'll call I, integral value, h over 2, 0.25 over 2, which is 0.125. We can write that down straight away. y0, this one, plus the yn, which is y4, which is here, which is 1, plus 2 times. So I put another brace there. These 3 middle values, 0.70989, 0.73030, 0.79603. Close the brace, and then close the other brace as well. There we go. Tap that in the calculator then, and see what we get. So I'm going to try and move my calculator slightly out of the way, so I can see all the numbers. So it's 0.125 times, bracket, 1.7071, 7 0.0711 plus 1 plus 2 times bracket 0.70989 0.70989 plus 73030 0.73030 and then 79603 0.79603 close the bracket equals 0.772 to 3dp, isn't it? 0.772, and that's the 3dp when we've done the final calculation.